Greetings from Goblin Valley, Nissedal, Norway. I'm here so you don't have to be. First of all, thank you so very much for the effort you have put in to this experiment. I think we have enough data now to reach a conclusion. Not very clear cut as we might have wanted, but we'll come back to that. This video, first we will look at the datasets. Then we will look at the datasets again. Then I will admit I have been terribly wrong again. And although it's one step backwards, it's also 10 steps forward. You'll understand it. But yeah, I'll have to swallow a camel or two. So after that I will present to you a new hypothesis based on my own data sets. They are too complicated to show and it takes too much time, but I will talk about my own experiments for now the last 10 days, and I will forward a new hypothesis and I will invite you to a new experiment. So it's all going to be very, very fun again. So let's just go look at the data sets. Single or dual coil, does it matter? Yeah, let's find out. Now this is fairly simple stuff, so let's be quick about it. Top left you can see single battery, single coil. This is the first data set. It's what you can call the base of this endeavor. In the diagram with the columns, you can see below the columns that is milliliters of e-juice from 6 to 25 milliliters. On the vertical to the left you can see numbers of vapors from 0 to 16. So if you look at one data set like 7 milliliters, the pale blue, the cyan blue column to the left, at 7 milliliters we have 14 results. 14 vapors clocks in at 7 milliliters of e-juice per battery charge in a single battery, single coil setup. Now it seems like there is a broad consensus that 8 milliliter is where most people come in. Now I haven't made a total average because we have results like to the far right. One person clocks in at 25 milliliters, and that is just astonishing. So I prefer to look at this in two ways. We can say that most of us, like 70-80% of us, comes in at 8 milliliters and then it tapers off. Or we can look at this as two isolated groups, where the group to the left are the norm and the group to the right knows something or uses their equipment in a way most of us do not. I'll come back to it when we go through the datasets again. But first of all, one battery, one coil, 8 milliliters. Now this is where the fun starts. And this is single battery with dual coil. And this is the question we have asked ourselves. Now, you can read statistics as the devil himself. Everybody knows that. You can interpret to your heart's content and make it tell you whatever you want. So you can look at this as, again, two separate groups, or you can look at this data set and think that most of us come in at 4 milliliters and then it tapers off to the right. Now it's clear that the more complicated things are, the more batteries and the more coils from single setup, the spread out it's larger, and that is to be expected. Now, when you look at the numbers, you can see that 60% is between 3 to 5 milliliters on this setup, and 40% scores 7 and higher. And to me, this is a very, very clear indication. The data set is of course not the biggest one, but compared to my own data too, it looks like a dual coil setup only goes through half of the E-juice as in a single setup. Now that is just something we can look, and we basically just have to accept it. Again, we have outliers, and this time quite a few that scores high, and even a crazy vape head again at 18 milliliters on one charge with dual coil setup. Let's move on. This illustrates the problem perfectly. Now we have 3 batteries and 2 coils, and there are just not many enough numbers to draw a clear conclusion. But I would like to think that the top is at 12 or 13 milliliters and then tapering off. And because triple battery dual coil is an unusual setup, we have to conclude that some really advanced vapors with a very fine-tuned setup is using this setup. And we have outliers at 25 milliliters and 30 milliliters of E-juice, and that is astonishing. But it makes sense when we come to the end of this video. But for now, let's just pretend that if we extrapolate the data and says that 1 battery, 1 coil, 8 milliliters. 1 battery, 2 coils, 4 milliliters. And if we take 2 coils and 3 batteries and do 4 times 3, which is probably very incorrect, we end up with 12 or 13. But yeah, something like that. At least we can see we have 2 separate groups, and that is something. But this data set is lacking in numbers. So let's move on. Here again we can see the statistics for dual battery, dual coil results. And yeah, you can choose to see this as a continuous curve, or you can choose to look at this as 2 groups, where one is the standard normal and the group to the right is exceptionally skilled vapors. Anyways, 65% of you comes in between 8 and 10 milliliters in that group, and 35% of you scores 15 milliliters or higher. Now the mathematics in this is of course 1 battery and 1 coil clocks in at 8. So dual battery and dual coil results. Now this is really complicated because we have 4 variables and a lot more going on, but 8 to 10 milliliters seems to be the consensus here, with the outlying group to the right. And this also makes perfect sense, both that the majority of you scores around 8 milliliters and that we have this huge group to the right. I mean, it's 35, almost 40% to the right that scores very, very high. Yeah, let's move to the last group. This is the very few and special dual battery single coil users, and they score consistently very high. Now, because there are so few numbers, you can interpret this any way you want. You can see, well, they're spread out from 14 to 24 milliliters, and that places them around 18 milliliters. And if you consider that one battery, one coil, gives you 8 milliliters, you would expect the people to land at around 16 milliliters. And let's say we have a group tapering out to the right again, up to 24 milliliters. Now, it's really hard to reach any conclusion, but let's just agree that this group fits in with the rest of the datasets. There is nothing in this dataset that indicates that the conclusion that a dual coil setup demands twice the energy is wrong. So let's go back and look at the first image, the first dataset once again. This is actually a comparison between single battery single coil and single battery dual coil setups. I hope the number shows up in the video, but anyways, the trend is really clear. Because you have a peak at 8 milliliters for single battery single coil setup, and you have a peak at 4 milliliters for the single battery dual coil setup. And yeah, in the more basic, simpler setup, there are more consistency. In the other dataset, the tapering is not as steep to the right. And we can make the hypothesis that a dual coil setup uses twice the energy to evaporate X milliliters of e-juice. So let's go back to personal view, and I'll talk a little bit about my own setup and a little bit about the factors that determines how many milliliters you actually can vape. For this part of the video, remember, better means more energy saving and disregards the flavor and vape production to some degree. It's not a huge difference, but energy saving is better, and energy gobbling is worse. Now, my own data set that I have evolved for 10 days now, I have used the flimsiest flat wire coil at 0.34 ohms. I've used massive Claptons at 0.14, 0.16 ohms. I've tested Nye 80 stainless steel cancel, and there was really no big difference. Sometimes it was in favor 10% of Clapton coils, sometimes it was in favor 10% in flat wire coils, and always, almost always, it was 3.54 milliliters with a single battery dual coil setup, and consistently 7 to 8 milliliters with a single coil setup. And then I did two tests. I tested a single coil. Then I used steam engine to calculate the surface and the mass of the coil, and the ohm, and how to build a two coil setup identical to the single coil in mass and surface and resistance. I tested it on the same squonker. The Suicide King by Purge, it should be the best thing out there. And on top I had the Carnage RDA. That can be used in single and dual coil mode or setup. So everything was the same. I even could adjust the airflow. So that in single coil I used airflow from both sides. And in dual coil the same amount of air. And of course the same battery. Everything was identical except one thing. Now before we get to that, the results was of course a single coil 8 milliliters of e-juice, the dual coil 4 milliliters of e-juice in one charge. Now before we get to why, I think I figured it out. Let's talk about some high school physics. If you have a pot with on the stove with ice and water, the temperature in the water is 0 degrees. When you turn on the heat, it stays at 0 degrees until all the ice has melted. The temperature of the whole fluid needs to be 0 degrees and the ice has to be gone before the temperature starts to rise. Then it rises rapidly up to 100 degrees Celsius. And it stays at 100 degrees. It doesn't get warmer because the water is boiling. First, when the water is evaporated, the pot starts to heat up really, really rapidly. So we need for a fluid to go from firm form, I don't know what that is in English, to a liquid state, the whole mass needs to reach a certain temperature. And for a fluid to boil, the whole total mass of fluid needs to gain a certain temperature to boil. For water, that is 100 degrees. Now, the boiling point of PG is 188 degrees Celsius. The boiling point for VG is 290 degrees Celsius. Now, some of you might realize something here. It's not about the coil or the coil material. Flatwire or Clapton seems to really, it doesn't really matter. So I have been dead wrong about the energy saving capability of the flat wire. Well, actually right when you don't put your cotton and saturate it inside the coil. When you dry fire them, yes, it's 3 to 4 times as fast as Clapton coils. But in reality I have been dead wrong. They are actually quite similar. It seems to me, when you disregard the batteries, I have a lot of information about your batteries and coils, you see. You have posted additional info in the commentary field. It looks like the decisive factor here is the total mass of the coil. When you weigh a coil, and you weigh the coil with saturated cotton inside, the saturated cotton is like 80% of the weight of the total mass. And we know by physics that the whole fluid inside the coil needs to reach boiling temperature, at least 188 degrees Celsius, before it starts to evaporate. Now, if you have 2 coils, everything identical, except for one thing, the mass of the saturated cotton. That was the only difference. So I tested my theory out. I reduced the mass of the cotton from 3.5 millimeter inner diameter to 2 millimeter inner diameter. And you know what? I went up from 8 milliliters of e-juice, single battery, single coil, up to 15. It was no big deal at all. And Yeah, there are lots of these factors, like the mass and the surface and the materials and the amount of airflow and of course the batteries and the mixture of PG, BG. All little factors contribute here. But the question is, what is the significantly most important thing? Well, if you consider that the whole total weight of the coil needs to reach 180 degrees and that almost 90% of that is fluid, then you understand why 2 coils needs twice the energy of a single coil. And that's the reason why chain vapors seems to score very, very high, because the total mass don't get so cold so fast. So for chain vapors, Clapton coils is very much more efficient than a flat wire coil. Now let's move this on to an. Do I need to state the conclusion? Well, okay. Dual coil builds are twice less efficient than a single coil build. All other things being equal. Okay. Now, over to the fun experiment. Because I want to move all of you on the left side of the graph over to the right side of the diagram. And you can do so in a second or two. You put your, take out your ordinary coil, Clapton flat wire, single wire, parallel wire. It really doesn't matter. What matters is the volume inside. And I want you to take your pliers. You put it on a 2mm drill bit and you take your pliers and you yank it, like so. And you can put on an additional wrap. It really doesn't make much of a difference. Yeah, the ohm will change, of course, but I have done this experiment with changing ohms, and that didn't matter more than 5%. When I changed the diameter, I doubled the amount of liquid I could vape in a single charge. So yank on the coil legs on a 2mm drill bit and put it back inside. So this experiment is for 2mm inside diameter coils only. State the number of coils, state the number of batteries, and state the amount you vape in a single charge. I don't care how low you vape your battery, okay? Just don't destroy it. I want you to give me some additional information. If you use 21700 batteries, please say so. You guys are just killing the rest of the field. And if you chain vape, please state so. That's the information for this experiment. And this time I expect much more consistency. And I predict that we will move the whole left side of the group over to the right side. Now, this is a competition. Game on.